Let us take a look of how do we write the program to define a database structure in Oracle. So this lecture is serving as an overview for the data definition language. We will have more detailed data definition language programming classes to discuss how do we really write a program. But for this lecture, I want you guys to see what is a DDL looks like when you write a program in Oracle. Remember this picture? This picture saying that if you're going to create a database, you need to start with a mini world application, try to understand it. And then based on the mini world requirements, like our company database, we need to go into the data requirements as well as functional requirements. You did practice this part in your project number 1. And then based on the data requirements, you look into the conceptual design, which you try to define your ER diagram or EER diagram. So that is actually the part that we have discussed. Then we will move on. Once we have designed our ER diagram, we will move on into how do we map that ER diagram into the relational schema diagram, which is the topic we just finished. And finally, we will move into the coding part of the Oracle DDL definition to create the structure, which is really performing the relational schema diagram you design. And then we learn how to load the data into the database and make the queries out of it. And based on the data that you have created the storage to store those, you also need to implement the functional requirements on the other side to form the query functions in your database. That is the whole structure of the database design. Of course, we are at the level of be able to convert that design into the relational schema diagram, and based on the relational schema diagram, we learn how to write Oracle DDL code to really implement your design. And you can see one more detail is that on the design phase, it is not DBMS related. It is DBMS database management system independent. But after that stage, when we start writing the code, it will relate it on what software or DBMS you use to write a program. And let us take a look of what it looks like to create a table in Oracle. So in this lecture, you will have an overview about a DDL statement, and based on that concepts, you will see more detailed information, detailed lectures regarding to the real implementations, including how to create like the primary key, foreign key, etc. to add the constraints into the database you create. So let's take a look of an example directly. To create a table in Oracle, you need to start with the reserved word called create table. Oracle is not case sensitive. In the programs that I provide to you guys or in my lectures, I like to uppercase all the reserved words so that you can see what are the reserved words that you use and what are the variable names or the table names or attribute names that we can freely create. So you can see that if we start with create table with all uppercase, that means it is again a reserved word. Even if you put all of those things in lowercase, the Oracle will still be able to read it. Now create table student, that means I want to create a student table. After that, we will need to define what the table looks like. So you need to start with a parenthesis indicating the following codes are the codes that I want to do. And then end with the parenthesis and add a semicolon. And yes, your semicolon nightmare is here. In Oracle, semicolon means that you want to execute the code. And that means like this is the end of one big instruction. So you will need a semicolon. And we will use semicolon into the queries as well. Like I said, it is indicating that I want the DBMS or the Oracle to execute whatever I provide of the instruction. So that gives a creatable structure with an open parenthesis and a closed parenthesis and with a semicolon. Inside of the parenthesis, you can start defining the column or the attributes. So you can see that the very first attribute that we create is called student ID. Obviously, this is going to be something that we want to use as the primary key, and we define the data type. Not only the data type that is going to be CHAR, but we also need to provide the size of that data type. I have some slides to talk more details regarding to the data type following this slide. You will end with this column or attribute creation with a comma here, indicating, hey, that is one attribute I want to create, providing the name, providing the data type, providing the size of the data type of the declaration. And then we look into the last name, first name. Now we will see some very interesting data types that are only available in Oracle. That's called varchar2. That is going to be the variable CHAR data type. It can have a variable information to be stored in this data type. The 15 indicating that we can create as large as 15 spaces, and then whatever user input, like my last name is CHEN, it takes only 4 space, and then it will save all other spaces. In database design, the space is actually very crucial in terms of the storage space, and that's why we need to be as precise as possible. You can see that after the name of the column, the data type, the size of the attribute has been defined, we add something called constraints over here, and then give a constraint name and then specify what kind of constraints I want to put over here. These are the constraint definitions of the attributes that we try to create in this table. And again, we will have some more slides to talk about the constraints. That's saying that we are able to add the constraints to the attributes that we are creating. Those constraints including primary key, foreign key, non-null, check, etc. So you can see that we will have all of these things that can be added over there. After the last name and first name attributes are created, you can see that we try to create the address information. Starting with street, city, both of them are varchar because there can be any size of the words that can be input over there. State, we have some abbreviations over there. We can also set up as default for New Jersey. And then zip code. The zip code is actually a very good example of using CHAR because that you know it's going to be 5 numbers that you want to put in over there, and those numbers are not really numbers because we cannot do any calculations on the zip code. I mean, we can do some calculations on the zip code, but it won't make any sense out of it. And therefore, after that has been defined, we'll be able to define some other things, start term, birth date. You can see the birth date is using a date data type here to indicating the type of the date. And because date is pretty common so that you don't need to specify anything else, the Oracle will take care of that for you and some other informations that we can add. So you can see that at this stage, we are able to create all the attributes that we want to develop for the student table. And while we are doing those attributes definitions, we call this part of the code as the column level definition. So in this case, we would be able to add constraints, almost all constraints at the column level. And on top of that, after we define all of the attributes, we will enter into what we call the table level part of the code. So you can see that once we define all the attributes, it is the place that we are not going to define any more attributes, and we will enter into a zone called table level. So we can also add the constraints at the table level. Obviously, by looking into this case, you will understand that we add a constraint, give us constraint name, indicating I want to set up the primary key for the student ID as our primary key. So you can see this is a primary key constraint. We can totally add this constraint when we are defining the student ID as well. So we will discuss more about the constraints that we want to develop for the table creation. So this is, I give you an overview of what it looks like to create one table. Obviously, in your database, you have more tables need to be created, and they would connect with each other through the foreign keys. And we will discuss everything in the DDL topic of the Oracle implementation. So you can see now a table is an object that can be stored data in Oracle database. When you're creating a table, you must specify the following things. You need to talk about what is the name of the table, in our example student, the name of each column, data type of each column, and the size of each column. And obviously constraints that you want to add into the table. The constraint is not listed over here simply because it is totally possible that after you create the whole table without adding any constraint, that's totally fine. It's just that you can add more constraints to the table when the table is created. So Oracle provides you with the following different constraints. You will be able to specify the primary key, and sometimes the primary key are composite primary key, indicating that more than one attributes are underlined. To define the foreign key in the table and that reference another table's primary key, we can also do that. We can set the data validation, so that say the total amount of hours you can work and not more than 40 hours, something like that, to specify whether a column can be null or specify if a column should have unique values only. Obviously, if you set up a primary key constraint, it is going to be unique immediately. This is saying that for the attributes that are not primary key, and if you want them to be unique, you can still do that. So when a table is created, each column in the table is assigned a data type. And some important data types that I want to talk about are the following three data types: varchar2, CHAR, and number. And you should have a very good understanding of those things already. For varchar2, it's going to a character data type to store variable length alphanumeric data in the column. So this is obviously very, very flexible. So these are the two examples that we have seen already. Street, like 201 Donaghy Avenue. That's obviously everyone has different address formats. The length is going to be different, so that using a varchar2 is actually a very safe way to store the information. City as well. So if the data are smaller than the specified size, only the data value is stored, and then everything else would be taken away so that we can save some space. Varchar2 is the most appropriate type for a column whose values do not have a fixed length, such as the name of the company, name of the person, address, etc. For CHAR, it's going to give you a fixed length alphanumeric data in a column. So it's very similar to varchar2, it's just that it has a fixed length. Obviously, this is going to give you a more efficient, no matter it's in the storage space as well as the execution speed. The CHAR data type used to store more efficient and process data faster than the varchar2 type. So if you know the exact numbers, how many numbers that you need or how many characters that you need, you want to use CHAR instead of varchar2. Zip code, social security number are two good examples. Again, although they all look like numbers, that doesn't make sense for you to do any calculations on those numbers. So CHAR is actually a better way to store those numbers. Number. The real numbers that we are going to look into is actually have several variations, and it is very interesting to take a look at this. Number. An integer is a whole number without any decimal part, so you all know that. And therefore, if you want to define some integer numbers, then what we can do is simply put number with a parenthesis indicating that how many digits that you will need if that is going to be an integer number. So salary number, parenthesis with 6, that can hold 6 digits of the number. So what if someone is making 7 digits? If you define 6 digits, then it cannot hold 7 digits because the domain of this attribute is going to be 9999999, and if you have someone making 7 digits is outside of the domain, obviously the database will reject if you're going to input someone's salary that's outside of the domain. So you can either go back here, change this value, or you cannot including that person into the database. Age is the same thing. If we put number parenthesis of 2, that means you can hold some numbers from 0 to 99. And if you have someone that older than 100 years old, then sorry, this database cannot hold it. Therefore, when you design a database, you also need to put all of these things into consideration when you are implementing the database. The number data type is used to store negative, positive, integer, fixed decimal, and floating data numbers. So if we are not really only holding the integer, we need to make some changes. So when the number type is used for a column, its precision and scale can be specified. When we are specifying 2 numbers instead of 1, that is when we can hold some decimal numbers. So precision, indicating the total number of significant digits in the number, both to the left and the right side of the decimal point. That means how many numbers that you need to hold for one single variable. That's very obvious, right? And the computer need to generate right amount of space to hold that number. And how about how can we handle the decimal? The scale is the one that we're going to help us to do that. Scale is the total number of digits to the right side of the decimal number. And therefore, decimal number has specific numbers of the digits to the right of the decimal point. So saying that if the price column has the values in dollars and cents, which requires 2 decimal places. For example, if we have a value like this 2.95, 3.99, 24.99, to hold this kind of the data, say using 24.99 because it is the largest values that we need to hold, we totally need to hold 4 numbers. So the precision is 4. And since there are 2 numbers on the right side of the decimal, the scale is 2. And therefore, if we could put number 4 and 2, that's going to be the right number to hold the values that we are looking at. So let's have a very quick practice. Bring out your pen and paper. You don't need to submit this one. This is something very simple, but I want to make sure you guys understand about it. Saying that we want to purchase a house, and the house is going to cost $150,000 and $00. So saying that we want to hold this type of the value, what is the right data type and size to design for this attribute? So please write down whatever you think it is. What is the right number design? Obviously, you need 2 numbers to put in here so that you will be able to hold this whole numbers here. The answer is going to be number 8 and 2, because totally we have 8 numbers and 2 numbers on the right side of the decimal. So the precision is 8 and the scale is 2. So that is how we will be able to look into the numbers. A floating point decimal numbers has a variable number of decimal places. To define such a column, saying that we are doing some scientific calculations, they can go pretty large. And we don't really want to specify the precision and recall, but we still want to hold a number. So when that is the case, we can simply use number, number, the same data type without any parentheses. This number will going to be a floating point number. A value can be stored in it with very high precision. So that is one of the way that handling the things. But of course, the speed and as well as the space will have not going to be optimal. So now if we take a look of the student table creation example, you can see that for most of the data types that we have defined over here has been discussed, and the date is simply the date. Now, this slide tells you that other data types that you can use. So basically have covered the first several ones over here. They are just like your C++ of Java has many different kind of data types, but you usually only use the one that frequently use. This table shows, of course, not a complete list of the data types that you will be able to use in Oracle. Now let us take a look at the constraints. There are two types of the constraints that you can define. One is called integrity constraints that defines the primary key and foreign key. For value constraints indicating null, if null is available, if unique need to be satisfied, or non-null is going to be reinforced, those constraints are called value constraints. And therefore, you can see that the primary key and foreign key are considered as integrity constraint. In Oracle, we usually want to use the abbreviation of PK and FK to indicating the primary key as well as the foreign key. And in the Oracle DDL code, primary key is actually the reserved word. Foreign key is actually the reserved word for creating the constraints. The same thing for unique, check, and non-null are all the reserved words that we can use to create the constraints. Here are some abbreviations that we can use in naming constraints, in giving the name of the constraints. And we want to talk a little bit more about these constraints things over here. So you can see that if we take a look at the student table again, you can see that at the column level, we define two constraints. So how do we define constraints? We simply put the reserved word constraint indicating, hey, I want to create some constraints. After that, you need to provide the name for the constraint. And you need to understand, when I see the name of the constraint indicating it's just a name, just like when you're creating a variable name, it's not doing really anything. It's just a name of the constraint, but the reserved word here is doing the work, the real work. So that if you put not null, that indicating this last name cannot be null, basically. So you can see the red parts is the one that I want to show you highlight that these are the parts that the computer really cares about. So again, we would be able to create these 5 constraints in Oracle, and the reserved words are going to be given in this slide over here. So a constraint can be created at the same time that table is created, or it can be added when the table is created. And therefore, there are 2 levels where the constraints is defined. One is the column level, indicating that when you define each column, you also define the constraint. That's what we call the column level. And you can also define the constraints after all the columns are defined inside of the table creation, or later we can learn how do we do alter table so that we can add more constraints to the table that we already created. So if we try to create a column level constraint, reference a single column and it's defined along with the definition of the column. We see some examples over there. We can create any kind of the constraint. All constraints can be defined when the columns are defined, except composite primary key. Because composite primary key will take 2 attributes or more to be specified as the primary key. So if you do 1, saying that this is going to be the primary key, and when you try to define the next one at the column level, you are kind of conflicting with each other. So you are saying this one is going to be the primary key, and how about the next one? So you will have some error messages over there. And therefore, if you are creating some composite primary key for the table, it has to be defined at the table level, indicating that you have defined all the columns already, and now it is time for you to specify the composite primary key. For the table level, you can create all kinds of constraints at the table except not null. Not null has to be defined at the column level, because when you defining this attribute, you should know it can be null or not already. So that is the only exceptions for the constraints to be defined in the table level constraints. So you can see that we can define some column level constraints, we can define some table level constraints. Now, the last thing I want to discuss with you guys in this overview is the naming of the constraint. So try to observe, how do we name a constraint? If you see this, you can see this is actually a very object-oriented concept. Starting with the table name, underline with the column name, which is the attribute name, and underline, we use some abbreviations that we see earlier to specify the whole constraint. You need to understand, again, this is only a name. You can put your name here. You can put cat, you can put dog, whatever you want, because that is the name that we want to give to the constraint. Later, you can list out all the constraints in your in the database that you created to search for the information. But understand this, if we use a systematic way to give the name, not only you will not have duplications of the constraint name, but also you can understand what is this constraint trying to do by only looking into the constraint. So look into this one. This is saying that for the student table, for the last attribute or the last name column, it cannot be null. We can easily understand that, so that we can provide a systematic way to the name of the constraint we created. It's the same thing. We use in the student table, we use student ID to serve as the primary key. So it is actually very useful, and it basically focuses on the readability of the code. And therefore, if you try to create the constraint name, you want to use the table name, underline, column name, underline, and with constraint type with the abbreviations over here, so that we can easily understand the name of the constraints. So for example, again, even though we look into some tables that we have no idea, by looking into the constraints, say EMP, the employee table, using DEPTNO, department number, as the primary key, so that we can be able to understand what is the constraint trying to do for the readability issues. And therefore, that summarizes the overview of the Oracle DDL definition. Starting from this point, we will move on to the Oracle. In the next class, we will learn how to install the Oracle, and then we will be able to really start writing all the codes, all the things in Oracle environment.